All right, well, I hope everybody's having a good day today. Some of us are definitely more awake than when we walked in the door. Uh, Want to go ahead and move on with the next lesson. Just a couple things. Tomorrow is the end of the 6 weeks. So if you still have, like, say, your focus activities, or if you were wanting to retake anything, remember this afternoon by 4:20 was going to be the deadline. Both Mr. Yacht and I will be here until then. Or if you just have any questions, need to come on in. I think that's pretty much it. I mean, we'll go ahead and continue with the lessons next week. The only thing I'm going to go ahead and let you know ahead of time is next week. I'm not going to be here on Wednesday. I'll still be in the building because I'll be doing CAS interviews, but I'll have something for you guys to go ahead and look at in my absence, and we'll just see how far we can get. I will go ahead and give you another heads up. Not this coming week. It's the week after. I believe it's the week of the 11th. I'm going to go ahead and give you that entire week. We're not going to move on with any lessons. You have the entire class period every one of those days to work on your internal assessment. All right, so you can ask me questions, you can kind of use the Chromebooks, find some data, analyze the data. I mean, anything you need, I want to give you that time because on the 12th of December, that's when the rough draft is going to be due. All right, and then I think it's officially due on what, March 7th, I said? March 12th. Okay. All right, so unless there's any questions, we'll go ahead and get started. Okay.
For the IA, do you have some sort of like format, like template kind of guideline thing? Like for our psychology IA, she has.
Yes, at the very beginning of the school year, if you look at the Google class website and go back, so this is going back quite a ways. And this is pre-cal, so we want to go into math studies here. So if I go all the way back to week 1, okay, here we go. So I've got all kinds of different documents for what you're asking about. I've got an IA outline right there. There's a project checklist. I've got, what else here? Strategies to help you out with that. Collecting data and analysis. Yeah, so I have a lot of that information posted in that first week. You just got to scroll back to it. All right, anything else? Has anybody actually started writing your internal assessment yet? Okay, but we definitely have our data collected. We're looking at it. Okay, all right. But I do want to go ahead and give you time in class in the spring, sometime before the final IA is due. I'm going to go ahead and give you another week. So while you folks are working on your papers, I'll have sign-up times where people can come talk to me one-on-one. But the week after next, I'll just kind of be making my way around, and if anybody needs anything, just let me know. Okay. All right, well, let's go ahead and get to it. We are going to go ahead and start talking about number sets, significant figures, and scientific notation. So this is one of our really short lessons. We should be able to get pretty much all of it done today, maybe a little bit tomorrow. I'm thinking we're going to go ahead and end the 6 weeks just with taking class time to look at the assignment. That's going to be due on Monday. I'll let you know we have some quizzes next week. But okay, so you might remember the very first week when we came in, we did this as kind of a little review, kind of an introduction. You might even remember the exact set of notes. If you do, great. If not, well, let's go ahead and talk about it. Summary of the sets of numbers is provided below. So we have N, Z, Q, R, and then, of course, the empty set here. Well, normally we would say N, or what we refer to as the natural numbers, but in IB we call them the what? The cardinal numbers. In fact, what's the one group that you've been taught growing up, but that IB just doesn't use? Okay, the what? Well, no, we have natural. If they combine natural with the wholes, the only element difference between the naturals and the wholes is that the wholes had 0. So they're just going to go ahead and combine them into one set that we either call the naturals, or we can refer to it as the cardinal numbers. Okay, so Z represents your set of integers. These are your positive counting numbers that you've been using forever. They're opposites and 0. So the thing to remember about these cardinal numbers and the integers, no fractions, no decimals. Okay, you even notice we have notation here for the set of positives. You could even put a negative in place of the power, and that would refer to all the negative integers. Okay, so Q, this is rational numbers. So by definition, these are all the values that can be written as a fraction. That's why we have the definition here that all x, does anybody remember what this little segment means? Such that, okay, very good. And then we have our restriction. X equals A over B. We have our fractional value with the restriction that B can't equal 0 and A and B are both integers. Okay. And then we have R is going to be the set of all real numbers. And there is another one that we'll go ahead and list down here. All right, well, let's just go ahead and fill this in. What two types of numbers are the real numbers made of? Rational and irrational. Okay. So irrational, and rational. And then we can go ahead and kind of mark these out as we go. Okay, rational numbers. Now, we know what a rational number is. By definition, it can be written as a fraction. But what's an irrational number? Like, can you give me a number that you know is irrational? Pi. Pi is the perfect example. 3.14, you know, just keeps going. Also, another really good example is if you take the square root of numbers that are not perfect squares, like square root of 2, square root of 3, things like that are going to be irrational. So really think about those numbers that we just mentioned. There are two conditions that you have to have in order to be irrational. Anybody know what I'm referring to? Can anybody tell me one of those conditions? Just think about pi. What's that, Ellen? There you go. It has to have a non-terminating number of decimal places, so it has to go forever. That's exactly right. John Henry, I like the way you said that too. John Henry says it doesn't repeat in a discernible pattern. Yeah, if there's a pattern, you're going to notice that pretty quickly. But if it's something like pi, then yeah, it's just a bunch of random numbers, one digit after another. Okay, good, good, good. Now the rationals are going to be broken up into what two sets here? Okay, well, we can definitely have positive and negative, but take a look at the listing that I have remaining. There we go. So one of them is going to be fractions, and the other one's got to be the integers. There we go. Because an integer can still be a fraction, right? Like, give me the integer 5. How can I make it a fraction? Yeah, you can put anything over 1. It's going to become a fraction. There you go. So I'm going to go ahead and put the fractions right here. Okay, and then I'm going to go ahead and put the integers right here. All right. And of course, you'll notice because of the way I've got this set up, the integers can break up into either your positive integers, your negative integers, or 0. Okay. And instead of actually writing out positive integers, I'll go ahead and put z plus or z minus. There we go. All right. Do you guys remember doing this like the first week of school? This is going back months, though. Okay. Good, good, good. And then the other thing we talked about was significant figures. All right. And the way I explained it was think about having a map of the United States right here in the middle. Okay. And then what ocean is to the east of us? Or the east of the United States? Okay, that's the Atlantic. Okay. And then to the west of us, we have the Pacific. Do you guys remember where I'm going with this? You don't remember my talking about this? You're talking about the decimal. There we go. So either the decimal is absent or the decimal is present. Okay. Okay, so your number is going to be right here in the middle where America is, and then you're going to start counting at one end depending on if there is a decimal or not. And you're going to start counting at the first non-zero value. Okay, so if I were to come back up here, 5,032. The decimal is absent, so I'm going to start counting on the right side. But you'll notice the very first digit here is non-zero. So what would its number of sig figs be? It would be 4. Now, even though there's a 0 right here in the hundred spot, it is a placeholder, so it is still significant. Okay. What about the 2400? Okay, it's only 2, but even though I see 4 numbers, though, what was the idea? Yeah, remember, you start counting at the first what? First non-zero number. So I'm coming in from the right, so I don't start counting until I get to the 4. So that's 2. 32,007. How many sig figs does that have? 5. What about 5,000? That's only 1. Now, D and E finally have some decimals, so I'm going to start counting from the left side. So what about D? This is 3. See, I'm not going to start counting until I hit the first non-zero value. Now, even though there's 0 at the very end, it's still significant because it's a placeholder. So that would be 3 sig figs. What about the 6.016? That would be 4. Okay, there we go. And I do have several extra if anybody's still wanting to practice this idea. Is anybody having trouble with significant figures? No? Okay. Well, good. And then that's where we stopped. Because I said we were going to go ahead and move on with this eventually, and we're finally to that point where we can do so. As a general principle, if you do calculations with numbers that are accurate to, for example, 3 sig figs, the answers should be rounded to the same level of accuracy. Okay, so let's say a rectangular field is measured as 91 meters long and 75 meters wide. Okay, what's the area of the field? Well, what's the number of sig figs for each value? Okay, it's 2. All right, so we're going to go ahead and keep that in mind when we're working this problem. Well, in order to find the area of the field, well, what do? Yeah, just 91 times 75, right? So I'm getting an area of 6,825, and we're talking meters. So the area is equal to 6,825 square meters. But like this was talking about, if I start with my values being 2 significant figures, I want to go ahead and make my answer 2 sig figs. Does someone know?
Yes.
Oh. Hi.
Zing.
Yeah. Our youth is too desensitized to violence. That is a whole other discussion. All right. So now, right now, it's 6,825, but let's say that I wanted to go ahead and write my answer in only 2 significant figures. Since there's no decimal, I'd have to go ahead and start from the right side, but I only want to count 2 values. So basically, what am I going to be doing here? 6,800. There you go. So 6,800 square meters. Now, that's not anywhere near exact. We're just talking about how we round, and we're showing some examples. Ella?
So I think I asked this one, but if it's a whole number, like there's the decimal is absent,
Uh-huh.
but there's a 0 on the other end, so it's like 0, 1, 2, 3. Would you still count that 0?
Okay, so tell me the number. Like 0, 1, 2, 3. And it has the decimal point at the beginning?
No, there's no decimal.
Oh, there's no decimal point.
Like, would that be, like, will they ever give us a number like
No, because if there's no decimal point,
that?
yeah, there'd be no reason for that value. Now, if there were the decimal there, then absolutely that could happen. Okay, does that make sense?
Yeah. No,
Okay. Hey, Red. Oh, yeah. Okay. Now, were you talking? No, now.
Other side.
Oh, the other side. Oh, I see what you're saying. Okay. Now, this one, if I did have the decimal there, now it would be 4 sig figs. Or if I did go ahead, right now, 123 is 3 sig figs. But if I did go ahead and put 0.0, then that would be 4 sig figs. Is everybody okay with that? Okay, good. Good. I like decimals. They have a point. Anyways, find the area of a circle of radius 2.33 centimeters. All right. So, Amy, what was the formula for the area of a circle? Oh, don't remember? Laura, help her out.
Is it pi r squared?
It is pi r squared. Okay, very good. So pi r squared. So what we have here is pi times 2.33, that's a 2, squared. Okay, so I'm going to come on over to my calculator. Let's see what we got here. Now, there's several ways to go ahead and bring up pi. I like to use the button down at the very bottom left. It actually has several useful characters down there, but I'm looking for pi, parentheses 2.33, and then I'm going to go ahead and square it. So I'm going to go ahead and say 17.055 square centimeters. But the radius was given to me with how many sig figs? 3. So how would I write this number with 3 sig figs? 17.1. There we go. All right, so we'll go ahead and say 17.1, and we are talking square centimeters. I like circles too. They get around. They get around. Signa gets what I'm talking about. Sorry, I'm a little more into it today, because. Yes, ma'am. Typically, here's the thing. The general rule I've always seen on IB, if they don't tell you a certain number of decimal places or sig figs, the magic number is always 3. I would always go with 3 sig figs. Even if a problem like this didn't say it, I would probably just go ahead and give the exact answer. Now, if it's on one of those rounding problems where you have a decimal that goes for a while, I'm always thinking 3 is the best way to go. Okay. All right, questions. How's everybody doing? Okay. All right. Are you candy corn?
No, I'm pizza.
Oh! I was seeing it from the other side. There we go. That makes more sense now. Okay. So, well, sometimes I don't know. I mean,
I
there you go.
thought the hat was enough, just a little bit.
Well, I was thinking about. Well, see, I don't see that. All I see is this, and it was like a candy cane. So, anyways. Okay.
Pardon this interruption. The
No.
Lomax bus has just arrived. Please just arrived. Lomax. Thank you.
All right. Okay. Oh, I thought you were originally. Oh, okay. All right. Okay, so let's go ahead and get into accuracy and range of values. So a measurement is only accurate to plus or minus 1/2 of the smallest division on the scale. So this is an example here that's already worked out for you. Rod uses a tape measure with graduations in centimeters to measure his height. What's Rod's height range if he estimates his height to be 188 centimeters? Well, because the lowest division we have on that particular scale is in centimeters, well, we're going to go ahead and say plus or minus 1/2 centimeters to the amount that he measured. So 188 plus or minus 1/2. So you'll notice if you subtract 1/2, 187.5. If you add 1/2, you're going to get 188.5. But when you set up the range like this, you always include the bottom value, but you don't include the upper value. And it gives the reason like that. Note that the upper bound does not include the value of 188.5, since 188.5 would round up to 189. And remember, we were talking about within 1/2 of that smallest unit of division. Okay, so let me give you an example. Write down the range of values for the lengths of 8 centimeters measured to the nearest centimeter. Okay, well, I'm going to go ahead and take the 8 centimeters plus or minus 1/2, okay, the measurement of the smallest graduation that we have there. Okay. Oh, no, we're just going to set it up like the previous ones. Yeah, because a lot of times they'll ask you for these ranges. So this is going to be easy. What's 8 minus 1/2? 7.5. And I'm just going to go ahead and say x. So less than or equal to x, but less than 8 plus 1/2. 8.5. Ooh, the 8's red because it's Halloween. There you go. All right. Okay, and that's it. That's all there is to it. Okay. You want to try the next one on your own? Okay. Try the next one. So it says 7.0 centimeters measured to 2 significant figures. Okay, so this one is actually giving you something different. So there's a reason it gave you that decimal value. Okay, so let me go ahead and give you a second to kind of think about that. Okay, is everybody ready? Everybody thinks they have the range of values? Okay, here's what we should be getting. 6.95 less than or equal to x, which is less than 7.05. Okay, did anybody catch what I was saying? Okay, how many people just went ahead and did the 6.5 to 7.5? Okay, now, why is there a difference here? They just gave us 8, but here they gave us 7.0. They even said it was to two what? Two significant figures. So you have to be a little more careful when you're trying to find the range of values that applies to a measurement if it's a decimal number. See, the reason is because this is two significant figures, because that 0 is important to us, we're going to be taking 1/2 of 1/10 because that's the tenths spot. Okay, so think about what's 1/2 of 1/10. 1/20. Okay, so this is 1/20, but 1/20 actually turns out to be 0.05. That's what I would be adding and subtracting from the 7. See, that's where I got the 0.95 and the 0.05. Again, I included the lower value, but I didn't include the upper. Okay. I know. I know. It gets a little strange here. But I did check this with Mr. Reeves. Okay. So normally I would have the confidence to say, huh, but now I have double the confidence. Oh, actually, yeah, that's good. Say that again, sir.
Anything like 7.0 is only two sig figs for that range, 6.95 to 7.05, anything within that range would round to 7.0. That's the reason why that lower bound, the 6.95 is less than or equal to. It's equal because 0.95 will round up, but it's not equal on the other side because 7.05 will go up to 7.1.
Oh, thank you. Okay. All right. You ready for another one? Okay. Now this one we'll go ahead and talk about together. It says discs of radius 2.23 centimeters measured to 3 significant figures are cut from squares of metal with side lengths 5 centimeters measured to the nearest centimeter. State the range of possible radius lengths of a disc. Now this is a decimal value, so we want to be careful, but how many decimal places do we have? There's 2 this time. Now, if there's only 1 decimal place, we're going to be taking half of 1/10 like the previous problem. But now because there's 2, we're going to be taking half of what? 1/100 because there are 2 decimal places. Now, this is going to give me 1 what? 1/200. Okay, so I'm going to go ahead and take that 2.23 and I'm going to add or subtract the 1/200. Okay, you just have to be careful with the decimals. You can't forget to go ahead and multiply the 1/2 times whatever number of digits you have. And 1/200 is just going to be 0.005. Okay. So somebody help me out. We're talking about the length of the radius, so I'm going to go ahead and put this right here in the middle. Okay, I'm going to include the lower, but not the upper. So what is 2.23 if I subtract 0.005? 2.225. Is less than or equal to the radius, which is less than 2.23 plus 0.005. .235. There we go. Okay. All right. You just want to be mindful of those decimals if you're looking for the range. Now it says state the possible, this is the range of possible side lengths for the square, but you'll notice it just gives me an integer value, so I don't have to worry about this here. It's simply going to be 5 plus or minus 1/2 centimeters. Okay, so this one is just like the original. So what would your lower boundary be? 4.5. Less than or equal to side length, so I'll go ahead and say S, which is less than 5.5. All right. Well, let's take a look at this one. In an experiment, it was determined that A is equal to 2.16, B is equal to 3.50, each to 3 significant figures. What's the range of possible values for A times B? Okay, so you want to go ahead and do the same operation for each of these values. Okay, and then I don't want to say too much. I want to see if you can figure it out. Okay. So we're going to do one for A, and we're going to do one for B. Okay, now don't say it out loud, but this is a decimal answer. Think to yourself, how many decimal places do we have? So we're not just adding or subtracting 1/2, it's got to be 1/2 of, okay. Okay, so is everybody ready for the range on A? Not yet? Okay. Now, we're not going for the final answer just yet. We need a range of values given A's length, a range of values given B's length, and then we're going to use those to go ahead and find a range for the product of the two. Okay, so let's see if what we got for A is correct so far. 2.155 less than or equal to A, which is less than 2.165. Did everybody get that for A? Okay. Here's what we should have gotten for B. 3.495 less than or equal to B, which is less than 3.505, I believe. Okay. Is everybody okay? So that's the range of values for both A and B. Now, here's for the product. Here's what I went ahead and said for a final answer. 7.53 is less than or equal to A times B, which is less than 7.59. Okay, now where did I get those values from? There you go. Okay, so I went ahead and multiplied these like the 2.155. 2.155 times 3.495, I believe it was. Okay. So I got 7.53173, and I just went ahead and rounded that to 3 decimal places, 3 significant figures similar to the original one. Ella?
How come you did not take your decimal
Out to the thousands? Because there was only 2 decimal places. Because it was only, what do we have here? 2.23. Oh, I'm looking at the wrong one. I'm sorry. 2.16 and 3.50. So you only had 2 decimal places. Now, if you had something like 2.165, I'm just going to go ahead and make one up. Then I would go ahead and say 2.165 plus or minus, 1/1000. Sorry, 1/2000. Because you'd be taking half of 1,000th at that point, because you have 3. But here we only had 2. So you were taking half of 100th. Is that okay? All right. So how many people got the ranges on A and B right? Okay. Is there anybody who went and got the product range? Okay. All right. All right. We're practicing. It's okay. Well, let's try another one. A piece of ground in the shape of a rectangle is measured to the nearest meter. Its length is 12 meters and its width is 6 meters. Write the range of possible values for the length of the rectangle in the form where A is less than or equal to the length less than B. Okay, so here's the length. Okay. Oh, do you want to try this one on your own as well, or do you want to work this one together? You want to try it on your own? Okay. So let me give you a little time to take a look at that. Now you'll notice 12 and 6, there are no decimals. So do I need to worry about 1/10, 1/100, anything like that? No. Just stick with a good old-fashioned plus or minus 1/2, in this case meters. Okay, so Kate, I hate to. Oh no, I hate to single you out. I was going to go ahead and ask how good is your Forrest Gump impression? That's awesome. Now I want to go watch Forrest Gump. That's a great movie. It's long, but yeah. Do you say white people culture? What?
I think everybody enjoys Forrest Gump.
No, but like I remember specifically like my grandfather, like he like had very strong obsession with it, so I've always
Wait. You said the whitest man alive? Mike Pence? I'm sorry. I'm sorry. Anyways, go ahead. Mother wouldn't like that joke. Okay. Sorry. Go ahead.
no, it's like I always associated it with him. And
So your grandfather did or did not like Forrest Gump?
I like love Forrest Gump.
Okay.
Like religiously watched it.
Okay. Okay. It was a great movie. I loved it. Yeah.
I like watching. I like hearing old white dudes reminisce about the good old days. It's like, what exactly are you referring to about the good old days? Like,
I think our conversation is kind of straying into something I don't want to be recorded talking about. So I'm going to go. Oh, hey, math. Okay, look. All right. Look, Jenny, we've got math to do. Now that's a horrible impression. No. From that day on, I was running. Oh God, I got to watch this movie now. Okay. Anyways. Yeah, that's a perfect Halloween movie. There you go. All right, so what's my range for the length? What's my lower value? Well, now we're talking about the length, so we're working off of 12. So 11.5, less than or equal to the length, which is less than 12.5. Would you guys agree? Okay. Now for B, that's the range of possible values for the width, which is 6. So now what's my lowest one? 5.5, less than or equal to the width, which is less than 6.5. Okay. Now it says C, calculate the minimum possible perimeter of the rectangle. Well, how would I do this? Take the two minimums, but here's the thing, how do you find perimeter of a rectangle? That's exactly right. Remember, we've got two widths, two lengths. So 2 times 11.5 plus 2 times, 5.5. And what will that give me? 34. 34 meters should be the minimum perimeter that we can get.
You have to wrap that. Oh wait,
Okay. All right. And I did want to go ahead and stop today and show you something special. So we'll just go ahead and leave this scientific notation for tomorrow. That way we'll come in, we'll just do that very quickly, and then I'm going to give you the rest of the time to work on your assignment, which you should be able to get done in the class period. Yes? Typically, like in this case here, I mean, you can't round it in a lot of some of those cases, like that previous problem, without getting the sig figs that you want. In this case, it turned out okay because we're still 2 sig figs. We have 2 here, but up top here for the length, those are 3 sig figs.
But your lowest one in the original problem is 6, and if you did the problem, it would still round to the range being 30 and 40.
Oh, okay, yeah,
34 and
yeah.
38, yeah.
Would you,
Okay.
so on a test, should we round that down to 1 sig fig?
I wouldn't. I would go ahead and just leave it as is. Mhm. Okay.